Memory operands. Memory Main memory is used for composite data. So what is composite data? Data such as array, structure, dynamic data, they are composite data. These kind of data cannot be directly stored in register. So we need to assign memory location inside the main memory for storing those data. But when we are performing some arithmetic operation, we need to bring this composite data to the register file. To apply arithmetic operation, we need to use this load operation. We need to use a load operation when we are bringing data from memory to register. When you are done performing the operation and we need to store the register somewhere or in some array, then we need to perform the store operation. So these are the two operations that we need to perform. So if I write here, let's say this is our register and this is our memory, that means the RAM. So when we are bringing data from memory to RAM, this is we call load operation, and when we are sending data from register to memory, main memory, this is called store operation. So we need to perform these two operations for when we are dealing with memory. Memory is byte address. That means when we refer to memory address 0, that means we are referring to first byte of the memory. When we refer to 1, we mean when we refer to 1, that means we are referring to the second byte, and then 2, 3, and so on. This is how byte addressing works. Now, byte is a very small space, only 8 bits of data. We can handle 8 bit of data with byte. So, but to access more data, we need more space. So, what happens is we work with words. We work with words. So what is word? Word is 32-bit data. So in byte, we have 8 bit. So to make it 32-bit, we need to cover this much memory. We need to cover this much memory. As we know, this is 8 bit. This is again 8 bit. This is 8 bit. So 8, 8, 8, 8. So this 4, 8 would give us 32 bit, and this is called this entire part is called one word. Now in this architecture we use word addressing. So when we say 0, that means we are referring to this part. When we say 1 address, that's a memory address, that is the so it will start from this part and so on. So this is word align. Now addressing MIPS is big endian. Big endian means normally we consider this one as MSB. This part is MSB, and then this one is LSB. So least significant bit and most significant bit. But when we are using MIPS, MIPS uses this one as LSB and this one as MSB. This is how MIPS addressing works. Now, memory operand example. So let's say we have an example which is again part of a C code. This is our part of a C code. So in this case, we can see that G is equal to H plus A8, which is a composite data. And obviously, as we have discussed in the last slide, that this is a composite data. So this will be stored in where? This will be stored in somewhere in memory. So when this is in memory, so what do we need to do? Since this is stored program architecture, so we need to bring this into the register file. We need to send this into register file. How can we do that? To bring something from the memory to the register file, what instruction do we need to use? We need to use load instruction. So we'll be using load instruction. But there is one question. See, there is an index A8. So how would you know where A8 is in the memory? For example, let's say this is our RAM or our memory, and these are the location where, let's say this is the first memory location where you store A1, and then you have location A naught, and then A1, and so on. So how do you know where A8 is? To know that, what you need to do, you need to know the address of this starting element, or which we call the base address, starting address. This is the starting address of the array, and remember that array is stored in a consecutive memory location, which means if we know the starting address of the array, which we call base, then we can perform some arithmetic operation to figure out the address of, let's say in this case, A8. Now, what is the minimum memory location, or the memory space that we assign for each element? We have seen in the last slide that we assign one word size. One word is 32 bit, which is 4 byte, and the byte is the minimum addressing that we use. We do not use bit, we use byte. So when we say zero, when we say zero, that means that when we say zero, that means we are addressing to the first byte, and then one is the second byte. So, but here we will be using word addressing. That means zero means the first word. Zero means the first word. That means the first 32 bit. One means the second 32 bit, and so on. So, if we have the base address for some way, then we can figure out the address of A8. Now, how can we do that? Let's see. So, since this is register of, we need to assign register for each of these variable. G is assigned to S1, H is assigned to S2, and base address of A is in S3, which means whatever the memory address of this array element, first array element, we save that in S3. We do not know what is that address, but just assume that that address is in S3. So the MIPS code for this C code would be something like this. What did I say in the beginning of the slide? We need to bring this one into some register. That means we need to perform the load operation. See, this is the load operation. LW is the load operation, and we are storing the value of A8 in register T naught. But there is a twist. See, there is 32, and S3 is the base address. So what is this? Where this 32 comes from? This 32 comes from this index, and this index is multiplied by 4. So in this case, let's say instead of A8 we have A3. So this would have been 12. Why this is multiplied by 4? Because this is, we are referring to word address, and one word is 4 byte. That's why we are multiplying this index by 4. Each time we have an index here, we multiply it by 4. And then we have this part, which is S3. S3 is our base address of array A. Now, if we add, let's say, whatever the content we have in S3 plus 32, if we perform this operation, then we can easily find the address of A8. This is what is happening, or this is what operation is taking place here. So if we perform this load operation, there is two operations are taking place. Two operations are executing here. One, this addition operation is performed, where after this addition operation we get to know the memory address of A8, and then we go, the pointer goes to that address, and it brings the value that is stored in that address to this T naught register. When we have the value in T naught register, then this is just straightforward arithmetic operation, where if we see this instruction, what is the destination? G, and G is stored in S1, so S1 would be the destination, and then H is stored in S2, so S2 would be source 1, and T naught would be our source 2. So if we perform this, then we get the result that we are looking for with this C code, or part of C code. Now, in this slide, we are continuing with an example, or this is kind of a new example, but this is just an extension of example one. Here, what we did is we have instead of having a register or having a variable here, we have an array here. So, what this means is that whatever the result that we get here will be stored in another array. So, how this would work? See, we already have discussed that for this part, we need to execute the load operation. But for this part, when we have the result, then we need to execute the store operation. So let's do it. Again, H is in S2 and base address of A, which is required for calculating the address of A8 and A12, is in S3. So if we have these information, then let's calculate this. So first we need to perform the load operation. This is our load operation where we are performing this load operations, which means the value of A8 is getting transferred to T naught. This is our load operation, and then we perform this addition, which is this line performs this addition, and then once we have the addition result in T naught, then what do we need to do? We need to store this value into this location, which means this is a store operation. So we store what, this value, which is this, to where, to this memory location. See, this is 12, so we always multiply it by 4, so we use 48, and the base address is stored in S3, so we write S3, which means it's 48 plus whatever the value we have in S3. If we perform this addition, then we'll get the memory address of A12, and that in that address, whatever the value we have in T naught after this operation will be stored. That is how this store operation take place. Now remember, there is a subtle difference between load and store, even though they are similar type of operation. But in case of load, this is our destination, but in case of store, this is source and this is destination. But in case when we are going to encode it, assembler knows how to handle this. We use the same format for load as well as store, but the operation is little different, because in case of load, this is our destination, but in case of store, this is our source. This is how it works.